Technology is advancing at a breakneck pace, and robotics autonomous systems, RAS, have become commonplace. But do you know what RAS exactly is? Watch this video till the end to discover the details behind RAS, as well as how it's used for military purposes. Robotics and autonomous systems are an interdisciplinary field of science and technology for constructing sophisticated structures with cognitive abilities. This includes topics like mechatronics machines, power sources, and drivers, actuators, sensors, data transmission channels, computer programming languages, multi-agent networks technologies, signal processing methods, AI innovations, semantic advances, along with many more. With the help of all these components, it can create distinct intelligent processes. Robots come in all shapes and sizes, with many forms from cranes to arms, snakes, or even humanoids. They can have wheels or legs and be vehicles able to traverse land, sky, or sea. The possibilities of robotics are vast. They include industrial production, logistics management, precision farming for agriculture efficiency, as well as autonomous driving and space exploration tasks, such as surveillance and rescue operations. Additionally, robots can provide commercial services like healthcare delivery systems including rehabilitation services and assistive living options like entertainment educational programs and social interaction outlets. Hence, the standards that impact robotic engineering are countless. While a few of these standards specifically relate to robotics, many other norms have been adapted from related disciplines such as electromechanical engineering, electronics, and information technologies, just to name a few. Additionally, some areas like production management and geographical information systems also contribute to developing appropriate regulations for the robotics industry. The value of robotics and autonomous systems, RAS, is easily seen in their strong economic influence, both as an independent industrial activity and by triggering a large-scale disruptive socio-economic effect across multiple markets globally. By 2025, the yearly market impact generated by advanced robotics and autonomous vehicles will be equivalent to what we see from mobile internet, cutting-edge materials, or energy sources today. Industrial robotics has been a permanent fixture in several of Europe's high-value manufacturing industries, such as the automotive industry, and must continue to be sustained and expanded throughout all major European industries. Moreover, robotics technology can influence numerous end-user markets and applications. It is anticipated that the professional service sector for robots will experience double-digit growth over the next decade, with SMEs opening new doors into these sectors. Maintaining this trend could prove advantageous not only for businesses but also consumers alike. Robotics is not only a key component in the manufacturing industry, but it will also have significant implications for everyday life. In the future, robots are projected to play an integral role in healthcare, agriculture, civil engineering services, trade and commerce industries, as well as logistics and transportation. Generally speaking, standardization efforts in robotics can be divided into four main categories. The first one is foundations. This set of rules and regulations covers the use of specific words and concepts that serve as a reference for other standards. Included within this are ISO 89787, Coordinate Systems, ISO 19649, Vocabulary for Mobile Robots, and ISO 8373, General Terms and Definitions. Next is robotic safety. With the emergence of artificial intelligence, robots have become more autonomous and are now being adopted in healthcare, agriculture, private homes, as well as automated driving. For this to be successful, it is essential that existing safety standards are revisited and new ones developed specifically for robot applications, such as wearable exoskeletons used for rehabilitation or worker support. The robotics community has recently called on authorities so they can establish testing procedures suitable to these devices through appropriate safety regulations. After that, there is robotics system integration and interoperability. Robotics has advanced to the point where they can contain multiple subsystems that must be efficiently integrated, such as dynamic control, perception navigation, task planning, and trajectory planning. They are also able to interact with other systems by means of additional interfaces. Extending beyond the realms of ICT and electromechanical engineering, robotics necessitates unique standards tailored to its requirements. For example, ISO 9409, mechanical interfaces, and ongoing work in ISO TC 299 WG6, as well as ISO TC 184 SC2 WG10, modularity for service robots. However, there remain areas that require additional research and development before these parameters can be fully realized. Emerging as the new industry standard, robot programming languages and communication protocols aim to simplify the integration of robots in complex systems. Manufacturers such as AB, Comau, and KUKA have developed proprietary standards like Rapid, AB, PDL2, Comau, and KRL, KUKA. As a result, innovation in this domain continues to progress with a heightened focus on standardization for enhanced efficiency. Robot operating systems are far more than traditional operating systems. They act as mediators between the robotic subsystems, perception, control, reasoning, and planning, to achieve complex tasks. They provide a powerful platform for all software components of robots, regardless of if they run on standard computers, controllers, or embedded devices. Furthermore, these platforms form an integral layer that connects the interconnectivity between them, allowing them to work harmoniously together. With knowledge modeling, autonomous robots have the capacity to quickly comprehend the objects they work with, their physical environment, and all of their objectives. This involves various methods that include signal processing, sensor fusion data analysis, and artificial intelligence algorithms for localization and mapping purposes, in addition to optimizing constraints. Every technique has a shared element managing substantial amounts of contextualized data that must be processed logically. To create, process, and disperse this data, complex sensor systems such as image processing or speech recognition are utilized. However, it's also retrieved from the web. To ensure that this activity is undertaken in an effective manner, applicable standards need to be adopted, for example, SQL, JSON XML OWL, and RDF for ICT, ISO 10303 for product manufacturing information, and ISO 11783 for precision farming from other domains. Although knowledge modeling for robotics is still being researched, there has yet to be sufficient stability established in order to create a set of accepted standards that accommodate the needs of all potential applications. Last, we have ethics in autonomous intelligent systems. In our modern world, algorithms, sensors, big data, and ubiquitous networking have become commonplace technologies in autonomous and intelligent systems that are profoundly impacting the way we live. Unfortunately, these advancements could ultimately lead to a lack of trust in technology due to their potential implications on our personal lives and social environment. For instance, our confidence in digital identity and data may suffer if we are not given back control. Furthermore, technological advancements can bring up various ethical issues, such as transparency or accountability, that need to be addressed. IEEE and all other members of ASANAS have come together with the aim to recognize and create standards for potential technical implications caused by these developments. Now let's talk about the role of RAS, particularly in the military. The combination of robotics and autonomous systems, RAS, and artificial intelligence, AI, could completely revolutionize the battlefield. RAS allows for a plethora of distinct platforms, not only weapons systems, to accomplish hazardous jobs, thus reducing the chances for harm to soldiers and Marines, as well as causing production costs for ground systems to drop drastically. As Russia and China press forward on their research of RAS and AI for military purposes, the United States must contemplate how to address this issue, particularly if it involves potentially deploying lethal autonomous weapons systems, laws, against U.S. forces. This is an immense challenge that has major implications not only in terms of national security, but also international relations as a whole. U.S. ground forces who embrace RAS and AI can reap a myriad of benefits, such as greater operational success with reduced risk to personnel, potential new force designs, improved institutional support for combat teams, revolutionary new operational strategies, and possibly more effective methods for boosting Army numbers by recruiting and retaining soldiers and Marines alike. The Army and Marines are making rapid strides in developing their robotic autonomy systems, RAS, and artificial intelligence, AI, strategies to make sure they meet near, mid, and long-term goals. Both of these services have a number of initiatives ongoing, as well as collaborating on various projects. In addition, the Department of Defense has established a number of programs such as the Joint Artificial Intelligence Center, JAIC, that are designed to coordinate efforts across all branches and develop DOD-wide AI strategies. To be ready for combat, the military needs a reliable and qualified team. However, integrating robotics and artificial intelligence, RAS and AI, into standard units brings up complex staff-related problems that Congress may need to consider. These include staffing variations, recruiting skilled personnel with advanced technical abilities, education in new technologies, as well as career progression opportunities. Ultimately, RAS and AI have the potential to revolutionize ground forces in many ways, from enhancing existing capabilities to introducing new warfare techniques. We hope this has been a valuable lesson on RAS and its role in the military. If you'd like to learn even more, make sure to subscribe now.